Bismillahirrahmanirrahim. Assalamu alaikum. Dear viewers, I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. So I hope you are enjoying well-being and I am thankful to you for watching the video. And to watch more videos, please subscribe my channel and press bell icon. So now let's begin. So our today's topic of discussion is nucleophilic substitution reactions of pyridine with respect to displacement of good living group, in which we will see the different examples via bromination or 1,2 or either dibromo derivatives of pyridines and also the pyridyl Grignard reagents. So first of all, this belongs to the displacement of good living group. So the halogens, nitro group, alkoxy, sulfonyloxy, and methoxy groups, especially at alpha and gamma positions, but not at beta position, are easily displaced with a wide range of nucleophiles. So that means if these groups are present at either alpha or gamma position of the pyridine, they may be easily substituted with a wide range of other nucleophiles. And these nucleophilic substitution reactions would follow the addition, elimination mechanism, and that would be facilitated by two main reasons. The first reason would be electron withdrawal effect, of the substituent, and the second one is good living group of these nucleophiles. That means that these nucleophiles act as a good living group and the attacking nucleophile would facilitate in the sense of electron withdrawing effect. So if the electron withdrawal by the substituent is higher and the living ability of the nucleophile of the already attached nucleophile is also high, then both of these cases would facilitate the nucleophilic substitution reactions. And in this way, the order of reactivity is gamma halopyridines would be easily substituted as compared to the alpha halopyridine, and that would be easily substituted as compared to beta halopyridine. That means if the halogen group is placed at gamma position, it is far easily substituted as compared to that situation where the halogen group is attached at alpha position. And this alpha halopyridine would be easily substituted as compared to the case where halogen is attached at beta position of pyridine. So let's see the example over here. At alpha position, it is attached with methoxy group, and it starts from this one. Okay, it would be our product with 2-methoxypyridine would be our product, and the starting material is 2-chloropyridine, and in this case it reacts with sodium methoxyridine under the presence of methanol, and when it would be refluxed, it is converted into this intermediate, here it is attached with chlorine. This is already present here, chlorine, and here it is methoxy group, that is OMe, and this would be converted into OMe. This is 2-methoxypyridine. What would happen here? It would be shifted to this position, and the chlorine group or chloride group would be eliminated. So this methoxide nucleophile has substituted this chloride nucleophile. And the other example is if this starting material is treated with PHSH along with triethylamine at 100 degrees Celsius temperature, the final product would be 2-thiophenylpyridine. This would be our final product. The fluorides, if the pyridine is substituted with fluoride groups, so we may say that the fluorides are more reactive than the other halides. For example, 2-fluoropyridines can be converted into 2-dialkyl aminopyridines using lithium amides at room temperature. That means the 2-fluoropyridine can be converted into 2-dialkyl aminopyridines. Using lithium amide. That is lithium amide and dialkyl, that is R2 dialkyl aminopyridine, NR2, and here any other group would be present. And if this is in the case of nucleophile with negative charge, here it is in this way, this is 2-fluoropyridine and it may be easily converted into 2-dialkyl aminopyridine via lithium amide. So this reaction is fairly easy to be proceeded in the forward direction, and it carries out at room temperature as well. And our next example is if 2-fluoropyridine reacts with piperidine, along with lithium and butyl and THF, then it is converted into here. This piperidine nitrogen with one lone pair would replace this fluoride nucleophile, and the nitrogen would become here in this way. This is our final product in this reaction. Then it comes the displacement of nitro group can be made the means for synthesis of these alpha and gamma fluoropyridines. If the pyridine is attached with nitro group either at alpha position, this position or gamma position, this one. So in this case, these nitro groups can be easily replaced with the help of fluoride groups, and these nitropyridines can be easily converted into fluoropyridines. And if we see, this fluorine has been substituted at different positions of pyridine at all the 5 positions of pyridine. Let's suppose. Then we may say that of the 5 fluorines in pentafluoropyridine, here 1 fluorine, second, third, 4th fluorine and 5th fluorine at position number 6. So in this case, out of these, all these 5 fluorines, and its name is pentafluoropyridine, the gamma fluorine is displaced, this one at gamma position. This gamma fluorine is displaced more rapidly. The gamma fluorine is displaced most rapidly. So for its reasoning, you may consult the research article whose DOI number has been given in the below mentioned data. So let's see the other examples in this case. The first example is with bromine and with nitro group over here. It is treated with BU4 NF with DMF, dimethyl fluoride and tetrahydrofurane, and in this case our final product becomes bromine would be attached as it is, and here this nitro group would be substituted with fluorine, and this would be our final product. In the other case, if only bromine is attached, and if it reacts with aqueous ammonia, along with cuprous sulfate at 140 degrees Celsius. Then our final product would be here, it would be attached with NH2. This is 3-amino pyridine. Then the other example is, if we take this 3,4-dibromopyridine as our starting material and treat it with aqueous ammonia at 160 degrees Celsius, then our final product would be, in this case, this gamma bromine would be replaced first and the amine group NH2 would take its position over here. So this point or this example leads towards that point, that if out of 5 fluorines or these 2 bromines, the gamma fluorine or gamma bromine would be displaced more rapidly. The next is pyridyl Grignard reagents. Pyridyl Grignard reagents are readily prepared by the exchange of bromine or iodine using isopropyl Grignard reagents. That if pyridine is attached with either bromine or iodine and we treat that bromo or iodo substituted pyridines with isopropyl Grignard reagents, then we may easily prepare these pyridyl Grignard reagents. For example, we will see the next one. First, the other point is that in the case of 2,5-dibromopyridines, the exchange is highly selective at carbon number 5. How it is selective? Structurally, this is 2 position, this is dibromopyridine, 2 and 5 dibromopyridine. When it would react with, the first one is isopropyl Grignard reagent, that is isopropyl MgCl, or it is MgBr, along with tetrahydrofurane, and then we treat it with this reagent. This is N-butyric selenium chloride, tri-N-butyl selenium chloride, and after that the only bromine at carbon number 5, this is 5, 1, 2, 3, 4 and 5. We start the numbering from that direction which is closer to the substituents. So we will go to this direction because this substituent is closer to this nitrogen, and this is position number 1, this is 2, this is 3, 4 and 5 and 6. So this 5 bromine at carbon number 5, this bromine would be replaced, and it is selective this bromine would be intact, and here this would be converted into N tribromine selenium. But in the other cases where any other group may take its position and we take that material as our starting material, then we see how does it react. The other dibromopyridines including 2,6-dibromopyridines also give clean mono exchange. That means if we consider any other dibromopyridine, for example the 2,6-dibromopyridine instead of 2,5-dibromo derivative or dibromopyridine, we also get the mono exchange, same like in the case of 2,5-dibromopyridine, but in this case this would not be selective at carbon number 5, rather here carbon number 2 may also be substituted. For example, this is 2 and this is, here another group is attached. Let's suppose it is Cn, and you may also exchange this bromine with any other halogen. So for your convenience or for your broad skill knowledge, we may change this bromine with iodine. You may consider any halogen here, either bromine, chlorine or iodine. In this case, we take number 1, we treat it at first with isopropyl Mg, iodine and THF at -78 degrees Celsius, and then for the second step we take this reagent as our reacting phase and we get here. In the previous example, this carbon number 5 was attacked and the reaction was highly selective. But in this case, this group at carbon number 5 would be intact and this carbon number 2 would be attacked. And in this case, first of all, this group would react at this position and this would go here, and after that this O negative would be treated with other protonic medium and that would abstract the proton from there. So in this case, here it would be like this carbon and then OH, this H, OH, and then pH, this one, phenyl group. So in this way, here the attack is facilitated at carbon number 2. So here comes to an end the nucleophilic substitution reactions for the pyridine. Thank you very much for watching the video. Stay tuned. Please subscribe the channel and press bell icon. Allah Hafiz.